Hello children. Today we will learn some basic terms related to reflection by a plane mirror. Not only a plane mirror, every kind of a mirror you can just correlate this thing, but some kind of terms will be changing along with their definitions. So let us see in our today's topic plane mirror, and that too few terms related to plane mirror, that to reflection by a plane mirror. So let me draw the plane mirror initially. So do remember here every time, like the plane mirror has one silvering, like one side of it will be silvered and the other side will be the reflecting surface. So I am representing the silvered surface with a grooved edge, you can see over here, and the plane edge or the plane side of it we consider it as a reflecting surface. So I can say this one as your reflecting surface, that is what you call as your mirror. Okay, so first definition what we are going to learn in this today's class was, straight away I would like to say, that is first one we are learning is point of incidence and is represented by O. What it is represented by? O, point of incidence. So I will just list out the terms over here. Make sure that you are making a note after listening the class straight away. Okay na? So first one we are going to learn as point of incidence and is represented by O over here. Sir, define point of incidence. So right. So what do you mean by a point of incidence is given by like the point on the the point on the plane mirror. See, this is your entire plane mirror, I guess, right now. So any point on this plane mirror, wherever you can say that the light ray got incident. So if any light ray was incident somehow like this at a point on the mirror, and that particular point I call it as point of incidence. It means the point where light ray is getting incident on the mirror, or you can say your reflecting surface, is called as your point of incidence directly. And next, second one, I would like to discuss about second statement as normal, or second term we can say as normal. So what do you mean by normal, sir, again? Okay, let us see the normal here. So if I just draw a perpendicular line, if I just draw a perpendicular line, and sir, where you will draw a perpendicular line, sir? Yeah. So I am going to draw a perpendicular line at point of incidence. I am going to draw a perpendicular line at a point of incidence, and perpendicular to whom, sir? Perpendicular to the mirror or reflecting surface, you can say. Perpendicular to the mirror or reflecting surface. See this line. So you can say an imaginary line also, you can say directly. So this is what you call as your normal. I say this one as your normal over here and represent it by N directly. So a perpendicular line drawn at point of incidence to reflecting surface or plane mirror. Or else you can define like this: the line drawn at a point of incidence and is perpendicular to reflecting surface or mirror. That to which mirror? Plane mirror is called as your normal. Sir, why did you specify plane mirror, sir? Because for spherical mirrors, the definition of normal will be of different kind. That is a different category, we will say. And next, third one. I would like to say about third one is incident ray. What is third one? Incident ray. Say that it is denoted as like in short form IR, I can say. So let me suppose incident ray. I would like to take an incident ray. So what is, how do you define incident ray clearly? You can say light is a form of energy, we are saying, right? So the path of the incident energy, the path of the incident energy striking the reflecting surface at point of incidence, or the path taken by the light energy about to strike the plane mirror at a point of incidence is called as incident ray, or else more easier you can write what is that, the light ray striking the reflecting surface at point of incidence is simply called as incident ray. Directly you can learn this one straight away, is called as your incident ray. And next, fourth one. And next one is fourth one, angle of incidence. I call this one as angle of incidence. And this angle of incidence, let me suppose it is denoted by I. Sir, what is angle of incidence, sir? So in the diagram, if you see over here, in the diagram clearly, the angle made by the incident ray with normal. The angle made by the incident ray with normal, this one, is called as angle of incidence. The angle made by the incident ray with normal is called as angle of incidence. And fifth one, you can see here, the next term we are learning is reflected ray. And say reflected ray, you can show it by RR. So what do you mean by reflected ray? Directly I would like to say that it is the light ray, whatever you are just taken, it is the light ray getting reflected or bounced. The light ray which is getting reflected or bounced from the plane mirror. The light ray which is getting bounced from the plane mirror, where it will get bounced at a point of incidence, it will be getting bounced from the mirror, and such a light ray we call it as reflected ray. And such light ray we call it as a reflected ray directly. See this one. So the light ray getting bounced from the point of incidence on the reflecting surface, I call this one as what? Reflected ray. And next definition or next term related to this one is, you can guess, that is angle of reflection. Directly you can guess, I think, I know that. An angle of reflection is denoted by R. So as usual you can say now the angle made by the reflected ray with normal is called as angle of reflection and is denoted by R. So what is this I called as angle of incidence? I called as angle of incidence, and R is called as, repeat it, angle of reflection. Very good. So thus these are done. And next term we are learning about this one is seventh one, glancing angle of incidence. See, there are two different things are there, that's why I'm just specifying clearly the two things. So glancing angle of incidence in denoted by alpha subscript I. So in the diagram I can say glancing angle of incidence is angle made by the incident ray with reflecting surface. Angle made by the incident ray with reflecting surface is called as glancing angle of incidence. And the next one is glancing angle of reflection. The next one we call it as glancing angle of reflection. Yes, what you guessed is correct. So I think you got an idea about this one. It is correct. What you guessed is the angle made by what? Very good. Reflected ray with reflecting surface or mirror is called as glancing angle of reflection and is denoted by alpha R. Now, if you observe the diagram clearly, an important point we are going to learn, that is quite important I can say, so I would like to write this one with other color. So that one is your angle of deviation. Sir, what do you mean by deviation, sir? Exactly. Say this can be denoted by D or Greek symbol delta. So you can say, you can just use this words D or delta in this way. Sir, let me say, please explain us, sir, what is deviation. See, if you just place the scale over here, listen, this is the original path of your incident ray, right? This is your original path of the incident ray. Sir, what do you mean by original path of incident ray, sir? See, what if there is no, what if there is no mirror? If there is no mirror, the incident ray would travel in this direction only. So that's why I call this one as original path of incident ray. So this is your original path of incident ray. What I can say that one as original path of incident ray. Now what happened? Due to the presence of mirror in the path of your incident ray, the light energy got reflected off the mirror in the direction of your reflected ray, whatever you have represented. See here, this one, whatever you just shown it here. See, this is the original path of your incident ray. Due to the presence of this mirror, this light ray got deviated in this path as your reflected ray. So therefore the total angle between, or angle measured between the original path of incident ray and reflected ray, original path of reflected ray and original path of incident ray and reflected ray is called as angle of deviation. That's it. Angle of deviation. So now let us measure this angle of deviation. So before going to that, I would like to label all these things. Say incident ray I would like to label AO, and reflected ray I would like to label as OB, and the incident ray original path I would like to represent as AOA dash. So if you say from the diagram, according to your geometry, you know that angle AOA dash, if you see from there directly from the figure, angle AOA dash is equal to a straight angle. I can say that is your 180 degrees. See from the diagram itself, you can say this one, AOA dash is your total 180 degrees. So in this 180 degrees, who are included? See here carefully, I, R and delta. These three together is 180 degrees. Write down, that's it. So therefore what you are going to get now this one when you write it. So I plus R plus deviation is equal to 180 degrees. So angle of deviation is equal to 180 degrees minus of I plus R. But we already know that according to the laws of reflection, angle of incidence is equal to angle of reflection. So since I is equal to R, therefore angle of deviation can be written as 180 degrees minus 2 times angle of incidence. So if you are having angle of reflection, you can even write in the place of I as R. So these are the few important terms related to the reflection of light by a plane mirror. I hope everyone understood, right children? Any doubt though, you can just comment under the video. So let us see the differences between real image and virtual image in our next video. So thank you all. Have a great day children.